Okay, pause and make a prediction. Well, sorry. Make a prediction of what it looks like for a velocity versus time and a position versus time graph for a ball thrown up and kind of the same height. Pause. Okay, everybody got something? I'm gonna give it a shot. Ready? Not bad, not bad. We'll work with it. We'll go with it. Okay. So, a little bit of experimental error here, but so this is throwing part. I don't care about that. That's some hiccups. That's good. How'd I go for you? Get it? Okay. If I would find the slope of this velocity versus time graph, what should I get? Ready? I don't know if you can read that. Negative 9.68. Pretty stinking close. Yeah, I mean, it's measuring devices. Good? I mean, that's pretty good. All right. Question. Go. Thumbs up when you have a guess. Have a conversation.
I would say okay, actually, so question kind of related, kind of not related. Talking about velocity, okay? My man is standing on a stool. He's not talking. Yeah, he knows what he's doing. So, I want you, like, when you toss a ball up and then it lands in your hand exactly where it started, does that mean the velocity has an average of 0?
Yes.
Okay, but
The speed does not. The speed does not.
But your velocity
Is because half the time it's negative.
Velocity is 0.
Because half the velocity, half the time it's negative velocity, half the time it's positive
And if you
velocity.
add them together, it cancels each other out.
If you, the equation is like final minus initial,
Right.
or sorry, final plus initial divided by 2.
So together it's 0, and then divided by 2, it's still 0. So your average velocity stays 0.
Doesn't stay 0, it just
Or
is.
it is.
Okay. Correct answer is Correct answer is C. What is the value of that? Negative 9.8 meters per second squared. Okay. Folks, if you were tempted to put B, then you are still confuzzling velocity and acceleration. Okay. Velocity is the reading of your speedometer. Acceleration is how quickly your speedometer is changing. Does that make sense?
But if you were driving, if you somehow drove up and you turned off, like you stopped accelerating, like pressing the gas,
okay,
you would slow down as you went up.
Exactly, you would go down because the acceleration of gravity slows you down at 9.8 meters a second squared.
Like the rocket. Like the rocket.
Yeah, I think I'm understanding this.
Does that make sense?
Yeah.
Yeah, I'm just studying.
Sorry, I don't mean to teach for you. It's just
You're good. You're good. All right. Give that one a shot. Just for a little bit. Not much, but just a little. Okay. Next question. Question's up. Correct answer is B. You don't need physics as a warm-up question. Okay. All right. All right. So this same scenario, but I'm asking for which one has a greater change in velocity. Tell your neighbor.
we're not talking about the changing velocity is acceleration. They're both extreme. As soon as it leaves your hand, it's like you're going fast. So they're both changing at 9.8 meters a second. This guy's an A. This is right after the question. Relative to physics. So, going by the question I asked you earlier about velocity and the average being 0. Relative to, okay, so let's say like I'm born in I'm born in a hockey match.
Okay, let's hang on to that.
Okay, fine.
Let me. We'll get there. Okay. What do you say?
C.
Correct answer is C. Okay. The rate at which they're changing is the same. Okay. Their final velocities are different, but their acceleration are the same. They both have acceleration of negative 9.8 meters per second squared for 1 second. They're going to have the same change in velocity. Okay. So the one that's dropped, its speedometer looks like this. 1 Mississippi gets up to 10 meters a second. The one that's thrown, let's say we throw it at 20 meters a second. It starts at 20 meters a second. One Mississippi gets to 30 meters a second. They both experience a change in 10 meters a second over that 1 second interval. You all right with that? Okay. Thumbs up when you have a guess. Have a conversation.
Oh my gosh, I was right. So this is the way it's going to take time. Yeah.
Was I supposed to say how? Sorry, never mind. I misread.
Correct answer is okay. I want you to mentally sketch what a velocity versus time graph would look like for this scenario. Just in your brain, what it would take a mental image. What would that look like? Everybody got thumbs up when you got something in your brain. Velocity versus time. Rock being dropped. Doing okay with that? Okay. Velocity is changing at a constant rate. At half the time, you're at half the change. Correct answer is A. Okay. Okay. Listen. If you're changing at a constant rate, if anything's changing at a constant rate at half the time, you'll have half the change because the rate of change is constant. You all right with that? Same scenario, different question. Thumbs up when you have something. Have a conversation.
I don't know. It's 30 meters long. So.
Yep, you're right. Nice, yep.
Okay. Mentally draw position versus time graph for this scenario. I'll give you a hint. Start up here. Thumbs up when you've got something in your brain, generated from your own brain. Looks like that. Good? Okay. Here's the whole time. Here's half the time. It's only dropped this far. Correct answer, C. Okay? Listen, is position changing at a constant rate? Is position changing at a constant rate? No. Is velocity changing at a constant rate? Yes. So half the time for velocity is half the change. That falls apart here. You got to think about when things aren't changing at a constant rate. Good with that? Okay. Got a demonstration for you. It's worth sticking around. So, if you have issues with strobe lights, close your eyes and pretend you're in a happy place. How much time? What's my countdown? Okay. So, what I'm going to do is I'm going to use a strobe light to try to freeze something in free fall. So I've got milk going to be dripped. And we're going to try to capture that drippage in a strobe light. Video people probably wish you were here because it's going to be cool. And I don't think you're going to be able to see it.
It looks like a.
Yep.
It's going up.
Sorry.
Dude.
Okay, see how we're dropping slow motion here? Notice the gap here versus here. Where's a bigger gap? Why is there a bigger gap down? So as it goes down, the gap gets bigger and bigger because it's speeding up. Is that not cool? Okay. So you make it drip out. This is just for funsies. Check this out. You can see it. It's white. Flex better. It's not as cool.
It's clear. Water reflects.
Pretty cool. This is just for, that's just kicks and giggles. Okay, remember your worksheet due on Monday. Someone turn on the lights, please, and thank you. Thank you. Have a good weekend.